My name is Sean, and I want to talk to you about Pion. Pion is a project that is a collection of open source GopherCC libraries, and it's all made by individuals. So to put that in layman's terms, it's a bunch of libraries, WebRTC, turn servers, ICE, and SFUs that are all written by individual contributors. It's not a commercial project. It's not backed by a single company. It was started by individuals who wanted to scratch an itch, and they believed that it should be easier to build these things. I'm one of the developers that works on it. Pion is made up of a bunch of individuals. These are some of the people that have contributed that have made it possible for me to come up and talk about it today. If you're interested in contributing, we would love to have you. So this is everyone that it takes to make it happen. So if you don't watch this whole talk, I hope you just watch this next 3 minutes, and I really want to convince you that Go is making a huge splash in the WebRTC space because of how easy it is to build things and the safety it is compared to C and C++. These are 4 things that really excite me. There are companies that I've seen that have built some really interesting things, and I think that people build even more interesting things when they realize what is possible with Pion. So Foreman's a company that creates an SDK that allows you to remotely control a robot actually over the internet. So what WebRTC does is it sits on that robot and it sends the video signals back and then an accepted binary input. And it's a protocol that's known in the browser and is known in the robot. And so right from my browser, I'm actually just pressing my arrow keys and I'm controlling this robot over the internet. And they ran this experiment called Play with Spot, and anyone could go to this URL and control a robot right over the internet. Here's another great one. Headroom is a company that's looking to revolutionize the conferencing space by adding computer vision and digital signal processing. So you can do certain things like instead of pressing a button to raise your hand, you can actually raise your hand. It'll recognize it. It will detect who's talked the most in the conference call. So if you look down in the corner, it says someone's talked 56% of the time, while the others have talked 20% and 12%. Since Go is so flexible, it allows people to do things like this. Instead of dropping a monolithic C++ application that's hard to extend, Go makes things so easy to build, so easy to deploy. Everyone that's watching this video already knows that. But I want to convince you that WebRTC is a technology that you should be looking into yourself. Here's a company, PyPacker, that allows you to play NES and classic console games over the internet. But it's a lot more than that. It recreates that experience of sitting on the couch with a friend and playing a game. You see on the right, you have 4 people that are playing this. They're all spread out across the world, but they feel like they're close to each other because they're playing this together. Their inputs are all going into the emulator, and it's a really cool thing to, especially when we were dealing with COVID and everyone were being remote, not able to travel. I had a lot of fun playing this. I would send this link to people, and we would jump in. And I think it's really great. This is another. Go makes it really easy to hook up an emulator and hook up a WebRTC process. Things are very unopinionated, and it gives interfaces that allow you to do what you think is best. Like that, this WebRTC implementation, it doesn't make an assumption that you're building conferencing software. It doesn't make an assumption that you're doing robotics. It just gives you these APIs so you can go build something revolutionary like this. And this is the last one, is WebRTC is also letting people build very interesting things around peer-to-peer. So Strive CDN makes it so you only have to download a file once within your local area network. So these 5 peers on the left-hand side, only one of them has to download a video file from the remote server, and then they can all exchange it peer-to-peer. WebRTC allows 2 web browsers to talk directly to each other, so they can just exchange the file. And then Go is really portable, and so they're able to build desktop clients, they're able to build mobile clients, they're able to compile to WASM and run WebRTC in the browser, all with just one SDK. So that's kind of high level, here's some interesting things, but what actually is WebRTC? So WebRTC is a protocol for the browsers originally. When it was designed, a lot of people they had in mind they wanted to do end-to-end secure connection between peers. So they want to be able to connect 2 web browsers, they want to be able to exchange multiple audio and video tracks, and they want it to be mandatory security. WebRTC also allows the exchange of binary data, so think control channel messages. You want to send a text message at the same time as you're talking to someone over video, or you want to share a file. And one really cool thing is this binary data can actually be configured to be lossy and unordered, so it acts like UDP. So So it works in high performance areas as well. These are places where HTTP can't make the cut. So you need to use something that, you can deal with lost packets and not deal with head-up line blocking. And then it's grown. So like now we have all of these WebRTC implementations. You can use WebRTC in Python, in TypeScript, in Go, in Rust, and these are all like pure WebRTC implementations. This isn't just using a library and calling through FFI. Like these are pure implementations. You can jump in, you can look and see how things work. And I think this is great for connecting these languages to each other as well. You can use this binary data channel, and I can send a message from a Python process to a Golang process without having to do like a pub sub server, or having to worry about setting up like some kind of protocol to send back to each other. I can do whatever I want, and I'm seeing a lot of really interesting things in the like DevOps space because of this as well. So if you're curious about like how WebRTC works and the protocols and like what it really is, the Pion community is also working on a book called WebRTC for the Curious. And you can go learn not just about the public APIs, but like the deep dive on protocols and how to make things work. Things like congestion control or error correction or NAT traversal. These are things that you don't really have to think about when building WebRTC, but I think it's really powerful. If you understand one layer lower, it helps you build things in a way that makes sense at that layer higher. And then of course, I wanted to give like a WebRTC in practice. So how to debug teaches you the sharp edges. And then for my own thing, I really love the history of WebRTC as well. We managed to get interviews with the people that worked on it in the past 10 years. And WebRTC also stands on the shoulders of giants. So I was able to get interviews with people that 20 years ago had worked on stuff that eventually led to WebRTC. So what does it solve? Before you approach a technology, you think like, I have this unique problem. Like, how is WebRTC going to solve that for me? And here's the things that WebRTC will solve that maybe you didn't even realize were solvable. So let's say you wanted to connect two Go processes. One's in the left network, one's in the right network, that each have their own private IPs, and you have one public IP. And you think like, there's no way that this computer on the left can contact the computer on the right. They're not routable. WebRTC uses something called NAT traversal, which allows you to establish a temporary hole in your NAT that other people can communicate with. Think automated port forwarding. So you don't have to configure anything. What it does is the WebRTC agent contacts a stun server, and the process of contacting the stun server establishes something called a NAT mapping. And that NAT mapping creates a public IP and port that if someone sends data into it, it's automatically routed to the computer that originally created that mapping. So I create the hole, and then I tell other people, hey, go ahead and send data back into me. So now anyone in the world can send data back to your computer without having to worry about it. That's super powerful. Now you don't have to run like a pub sub server. You could do like really interesting like multi-cloud solutions without having to have a central point of failure. I think there's a lot of innovation that can take place here without having to worry about this. WebRTC also solves the problem of staying connected on the move. So let's say that you want to run a process on your mobile phone, and users want to switch between Wi-Fi and they want to switch between cellular. If you're doing TCP and you're not doing multipath TCP, you'll notice when you switch between them that it'll try to switch, and if the process isn't aware of what's happening at the networking level, you'll hit a lot of congestion and you'll have to deal with the back pressure. WebRTC solves this with a nice restart. So it's aware of what's happening at the network layer, and it's able to switch between networks. It's able to measure like how much bandwidth is available, and it's designed with mobility in mind. WebRTC also solves the problem of congestion. So a lot of times people will think it's as simple as, okay, I want to upload a video. I'll measure my network. You go to network speed test and you say, oh, I have 50 megabits per second. That's how much video I'm going to upload. But that's not how the real world works. In this situation, you had 50 megabits per second, but then your coworkers joined the network, and all of a sudden they started uploading video. You have to divide that by how many people. So video isn't static. Like the quality and the bit rate that you upload has to be variable. And WebRTC solves that with congestion control. So the receiver of that video will actually send things like, I got these many packets, I lost these many packets, I have this much delay. And the sender is able to determine live, okay, thanks for that information, I'll adjust the bit rate. So it ensures that the viewers always get the best experience possible without having to worry about picking a default that's too low or picking something that's too high. It always finds what works best. WebRTC also solves the head of line blocking problem. So if you've ever, let's say you're sending telemetry data and you're sending very important real-time data, you don't want to give them the same priority, and TCP makes you do that. So what you can do with WebRTC is you can actually mark packets as, if these don't get delivered, don't retransmit them. So you send your telemetry data with a retransmit value of 0, but you send your important data with a retransmit value of unlimited. So if you were doing TCP, this is what would happen. Telemetry and metadata would block new data. But with data channels, I can make sure that new data flows unblocked and delivery is guaranteed through retransmissions. WebRTC also is a bundle of existing protocols, so I can quickly interop things, with existing protocols or existing software stacks. So WebRTC is reusing like RTP, which has existed in telephony for almost 30 years now. So that allows me to hook up a WebRTC agent to Asterisk, to FreeSwitch, to all these existing VoIP providers. I can hook it up to the browser. And as you build more and more things, you come to appreciate like having a standardized, well-defined API will allow you to build some really interesting things. So you can worry about the problems that are important to you and not so much like solving these protocol level things. So now that you kind of know like how WebRTC works at the high level, like let's actually build something cool. And here's some of the APIs that you have. So the first step with WebRTC is you have to do signaling. So with signaling, it's basically you share like, okay, here's my NAT mappings, here's the codecs I support, and this is how to contact me. So what you do is in Go, you would call new peer connection, which creates one peer in a peer-to-peer connection. You create an offer, and then you share that offer with the other side. The other side then responds with an answer, and you call set remote description with that answer. You're now connected. This is all the code it takes to establish a peer-to-peer connection. Once you have this peer-to-peer connection, then you can start exchanging binary and audio data, binary and media visual data. So let's send some data. I call create data channel, and that parameter on the far right allows me to control the attributes of the channel. So if I just send nil, that means that the channel is lossless and it'll be delivered in order. But let's say you wanted to do a channel that was tuned for real time. You can send a struct and have a bunch of different options. Once the data channel's been opened, because the other side acknowledged it, you can start sending text. My data channel opened, I send hello world. You now have sent a message to the other side. And here's what it looks like on the other side. On the peer connection, I set an on data channel handler. When a message comes through, I just print it. And I want to deploy this to the browser. So I can run my Go process and then I can go build and have a x86 binary. And at the same time, I can go build with WASM and run it in the browser. So now you can exchange binary data between the browser and your desktop. You don't have to worry about running some pub sub server. You don't have to worry about like any portability issues. It's really, really powerful. And the performance aspects of it are really exciting as well. And then here's sending video. So with sending video, you create a track, you add the track to the peer connection, and then we provide some helpers to read from files, but you don't need to do that, you can use your own. And then the WebRTC API supports sending samples, which is just like audio video, or sending RTP packets, which is already packetized samples. And here's receiving. You set an on-track handle, you see what codec is coming across, and you read RTP. Receiving media is a complicated topic, and Pion provides some extra stuff. So like when you get into it, you'll want to read about interceptors and jitter buffers and all these really interesting concepts. But the goal with Pion is you should be able to build something quickly that works, and then you read in and understand these topics deeply. So here's some of the open source projects, and I think this is the best show of why Pion is revolutionary for the RTC space and why Go has so much to offer. A lot of these things were built by people that had never had experience with WebRTC before, but they found it by using Pion. NS Remote allows a user to actually access their Nintendo Switch and stream the video frames over the network, so they can put on an Oculus headset and use and control a Nintendo Switch that's in a completely different, completely different room, or it's in their hand. So here I am that I'm fully immersed. And this is just like a first kind of demo. Like, this NS remote works with the Nintendo Switch, but there's no reason that, you couldn't hook it up to other game consoles, that you couldn't hook it up to a PC and use your desktop in a 3D space. There's a lot of really interesting possibilities here. And then anything that can view WebRTC could review the NS remote. So you could actually like stream your Nintendo Switch to your browser, or you could stream it to your TV. We're starting to see TVs that have WebRTC agents. There's a lot of possibilities here. Kerberos is allowing you to access security cameras directly from your browser. So a lot of security cameras use this protocol known as RTSP, which has two big problems. One, it's not accessible over like public internet because it doesn't have NAT traversal. And then two, that there's no mandatory security. What the Kerberos project does is you run the Kerberos agent in the network, and it makes these feeds secure and accessible via WebRTC. So now you have all these legacy devices that are available on the internet. Neko makes a browser available to multiple people at once. So right now I'm in a browser, but I'm actually accessing a browser over the internet. So let's say that me and you wanted to watch a YouTube video together. We would both load this up, and then we could watch it, and the video frames would be streamed perfectly between us. We can browse the internet together, we can shop, we can do lots of interesting things. And then people are actually building experiences on top of that. Like they're making an SDK out of this. This is another thing that was like built by a developer that didn't have a background in WebRTC, but felt that this was an interesting thing to build. Here's an open source project that demonstrates robotics and remote control. So on this teledevice, you're running a WebRTC agent, so you can control it via data channels, and then you're streaming its video output via WebRTC. And then right in the browser, I'm able to just use it and drive this robot around. And then WebRTC also gives us the possibility to bring conferencing to devices that didn't have those capabilities before. So the remote peer is in their browser, but here I am sitting in my terminal and conferencing with another user. There's no reason that WebRTC is a protocol that has to stay in the browser. We can put WebRTC in embedded devices, we could put WebRTC in, we could build like a pure Go process to make WebRTC conferencing secure and not have to run the risk of, C and C++. There's a lot of interesting things here that we could do. Cloud Morph lets you run process-heavy applications on a remote server. So here I am playing Diablo that's running in an AWS instance, but I'm just in my browser and I'm clicking around and it feels like it's installed on my desktop. I really enjoy this because I have multiple laptops. They're running Linux. I don't want to bother setting things up. I run this process once, I access it anywhere. And it's also really powerful because you could do things like have a GPU on the servers when you don't have one locally. WebTTY allows me to access my terminal over the internet. And I don't have to run my terminal through a third-party server. My terminal doesn't even have to be web accessible. Since WebRTC is peer-to-peer, I can do this in my home network without even running it over the internet. This is really powerful because you also don't have to install like a VPN agent. So I can, access my terminal without having to install additional software. I could be on a Chromebook. A lot of really great possibilities here. And you can also do WebTTY between two Go processes. You don't even have to use your web browser. And you can connect two computers that don't have a public IP and start exchanging terminal input, and you don't have to depend on a third-party service. Snowflake allows people to get around restrictive governments and IT policies. So one of the hard problems with Tor is you have to download the agent. But with Snowflake, I can just use the WebRTC data channels and right from a browser tab access the internet through other WebRTC peers. And then with Pion, someone wrote an implementation so that it can act as a bridge, so users can access the internet through a Pion node, and it's all via data channels. So you can't block it because people need Hangouts and Zoom, which is all running over WebRTC, but you're opening up the possibilities for people to access an unfiltered internet. WebWormhole is a project that allows you to share files. So instead of having to upload your file to a file sharing host and wait for it to 100% complete, you share the file peer-to-peer. And then since it's in Go, I can share my files between my desktop and my phone, my browser and my server. It's written everywhere. It's available anywhere that Go runs, and it has all these really exciting capabilities. And here's a really great one, is someone built a virtual reality experience using Pion. And so if you can see on the left that people's faces are actually imposed upon their avatars, and it was to recreate a virtual space that was lost because of COVID. So this theater company was actually putting on performances of like Shakespeare plays and other things like that. And you could build these really interesting 3D immersive experiences. And it also lets you do things that you can't do in person. Like, for example, you can do quick stage changes, you can do outfit changes. I think this is what's really going to see the innovation, because Go, it's so easy to build things quickly. And if I wanted to do this in C or C++ or something else that takes longer to build and prototype, I think there's so much innovation that's still happening when we get all of these different people and we give them these great tools. And there's even more projects in this. I just really scratched the surface of the cool things you can do. So go to github.com, awesome Pion, and check out some of the things, and then I want you to go build something. So building an open source project of your own, it's a wonderful experience, because you get to build something you're passionate about, and then you get to share it with others. It's something you own. Like, if you've ever wanted to get into open source because you're nervous about it, but you want to get into it, come and reach out, and I will help you, and I will explain, these are the things that do to help you be successful. Because I think long term you'll find a lot of personal happiness by owning your own software, and then it'll even bleed over into making you better at your job. When you've solved these problems on your own, they're not so hard at work. And then Pion needs you. If you're interested in contributing to the Pion project, we'd love to have you. There's some really great projects that use Pion, like Tor and IPFS, and it's a fun challenge. You pick the goals. If you want to work 4 hours on a Saturday, you can. If you need to take a month off, you can. It's this wonderful, empowering thing to do, to build things how you want, when you want, and do them the right way. So here's the ways to find me. GitHub.com/Pion is the project, and then I run a Slack channel that's on the Gopher Slack, and reach out anytime. I'm Sean-Dur, and I'm happy to talk. And then also we have a Twitter where I post interesting projects and big status updates and stuff like that. So thank you for listening. I think go check it out and reach out and ask interesting questions. And I think this is a chance to really build something that can have an impact on the world and push the space forward. We always look for that opportunity to build things. So reach out, and I'd love to help you make that happen. So thank you very much.